Yeah, kind of read oral history questions for Paul Laughton on and around the history of the creation of the Apple II DOS in 1977-78 at the Computer History Museum, August 14th, 2013. And thank you, Paul, for agreeing to do this.
Well, thank you for inviting me.
And it's an honor to be a part of this capture, this wonderful history. And so I've got some questions prepared, and we can diverge from the questions. We'll probably end up answering many of them in the previous ones. But
Okay.
I hope they'll help joggle all memories and capture this wonderful period of time. So first question I have is, Paul, could you give us a summary of your early history, where you were born and raised, schooling, and what were the formative influences in your early life, and how did you make your way into the field of computing and come to be in Silicon Valley at such an auspicious time in its history?
Well, gee, going back, I was born during World War II, and my father was an engineer at the MIT radiation laboratories. And he is what we'd call today a geek. He was very much into engineering, very, very smart guy who didn't have a high school degree, but he did work as an engineer. And he worked for the Navy after that, and I got interested in computers in, I guess, the early 60s. We went to the Naval Research Laboratory, and they had a computer on display, and I thought that was really kind of cool. Later at Virginia Tech, I took the only computer course they had available. It was a Fortran, and also in the electrical engineering department, we had an analog computer class. And so those were the two courses that I had. Around, I think it was 1968, there was a Scientific American magazine came out about computing, and it was just wonderful. I mean, it totally fascinated me, the things they were talking about and the possibilities, and real-time displays and Star Wars games. They were playing on CRTs, and it just, like I say, fascinated me. So I took my first job at the Applied Physics Laboratory at Johns Hopkins University, and I was called a system engineer, but I was really a glorified computer operator. And there I learned IBM 360 assembly language, 360 operating system, and it just got permanently in my blood at that point. Follow on, there was an ad in the paper for people to work on IBM 360 for the Air Force Manned Orbital Laboratory. This was the rotating, or the space station that was going to be run by the Air Force for spying. And so I got hired by Lockheed to come out here and work on that. I was here a month when it was canceled, which I guess is typical of contract work. After that, I went to work for IBM in their Call 360, Call 370 operating system. So I worked continuously on the operating system for 8 years. That and on languages. I did basic compiler essentially, but mostly operating system work. All aspects of it, the disk operating system, the time sharing, the networking, every last part of it. And that's how I came to be able to do Apple DOS.
So that answers the next question. So you had all the fundamentals down for real operating systems. So when it came to do a tiny operating system, you had all the components. You needed all the training and the background you needed to fit something into such a small machine.
Yes, actually, it was what I would call a piece of cake. The way of doing it was obvious. Everything that needed to be done was obvious. I had done most of the stuff in one way or another before, and so I was able to just sit down and do it.
And how did you meet and come to work with Bob Shepardson, and what projects was Shepardson Microsystems working on in the mid-70s, and how did he come to work with Apple on the BASIC interpreter earlier, for example, when you joined? I guess that was about that time.
Yeah, well, Bob was, he had worked on an assembler for the IMP-16 by National Semiconductor. He wrote the assembler under contract to National Semiconductor. He then modified that assembler to write an assembler for 6800. There was a character involved with Apple, a guy named Marty Sprigel, who tried to make money selling TV interfaces for the Apple II. And he was working with somebody else on a 6800 computer. And so he had contracted with Bob to write a BASIC for 6800. Marty, I guess, got scared off before that, sold it off to somebody else, and the BASIC never got written. Shep then proceeded to have a contract with Kermemco for a BASIC, for I think it was a Z80 BASIC. And while he was doing that, he was just finishing that, Apple was a few doors down. Very, very small company, 10, 15 people. And they were working on a new computer called Apple Annie. And they wanted a BASIC for that. And the idea of the BASIC was it would be in a cartridge. And so they knew Bob had written the BASIC. So they came to him and wanted him to work on it. Well, Bob was busy doing other things. So he put a small ad in the paper, and I responded. And his small ad was for somebody to come in and do the BASIC for Apple. And I had experience with BASIC. I had experience with many different compilers and assemblers. And I also had experience with the 6502. So Bob hired me right away. And then right away I started working on BASIC for Apple Annie.
So Annie, tell us more about Annie, because Annie never saw the light of day. Was it a follow-on to the Apple II?
It was supposed to be a follow-on. A lot of the circuitry that was in the Apple II was going to be put in larger scale integrated circuits. So even at the time, they had large scale integrated circuits. And like I say, they were going to have cartridges. The BASIC was going to be in a cartridge. Other things were going to be in a cartridge. The disk interface was going to be part of the main motherboard. And I really didn't know a lot about Apple Annie other than I was writing a BASIC for it. And about the same time we were writing it, there was a guy named Jeff Raskins who showed up and wanted more and more and more and more into this simple BASIC. We'd contracted for simple BASIC. We ended up naming it Not So Basic, NOTZO, because of Jeff Raskins continually changing it. That led to a need for another programmer. So Shep hired my wife, Kathy O'Brien, to help work on it. So Kathy and I ended up working together at Shep's. And we continued to work on this Not So Basic. And then one day, Steve Wozniak came in the office showing off his new disk drive. And he was showing it off to Shep. And he had talked to, I think his name was Gary Kildall of Digital Research, and about a DOS for Apple. And apparently Woz didn't really like Gary's approach. And so he just happened to mention to Shep that he was looking for a DOS. And I said, I know how to do that. And within 24 hours, that led to an agreement that I would do the DOS for the Apple II disk drive.
Now we see in the documents you provided that some in April of '78, that contract with between Shep and Steve Jobs. So was that happening around March, April timeframe? Do you remember?
Yeah, it was right. Well, the contract was signed pretty quickly after we made the agreement. Shep liked to get things in contracts without the aid of lawyers. You know, it was just quickly written up, and Jobs signed it, and I was on my way.
Gosh, so that you started as soon as that document was signed, and then the delivery was for early June of '78. So we're talking sort of middle of April '78 through to early June of '78.
Yeah, I don't remember those details. I'm sure you have better access to them than I do right now. But yeah, it was pretty quick. I knew it needed to be done, and I knew how to do it, and I was confident that I could do it pretty quickly.
So you were provided a set of specs from Woz and some handwritten notes. There's circuit diagrams, all in one packet in the beginning of your work. And then you had access to a mini computer with a 6502 emulator. Is that how it was?
No, it was a 6502 assembler. The basic DOS was written on 80-column punch cards. I would actually write out the code on 80-column punch card sheets and write it. And we had a guy at Shepardson named Mike Peters who would take those sheets and punch the cards. The punch cards would then be read into a National Conductor IMP16 and assembled and paper tape produced. The paper tape was read into the Apple II by a card made by Wozniak. It was a plug-in card to the Apple, and would read the paper tape in, and I would proceed to debug it.
So that whole process, how long would that process take? Did you have that next to your desk, like an ASR 33 attached to an Apple II with the prototype disk drives, or what did the setup look like?
The setup was I had an Apple II with a single Apple disk drive at the time, and it was an Apple II given to me by Apple, and Steve Wozniak came over and put in the extra 32K of memory. Steve Jobs. And it was, well, at first it was for the development of the BASIC. And then when I got the disk drive, it had the disk drive on it. My process usually was to write some code on these sheets of paper, and Mike Peters would type them up, and then he would eventually give me a paper tape, and I would run the paper tape into the Apple II and proceed to debug. And as the project got further along and the code was all written and it was debugging and updating, I would mark up a listing and give it to Mike Peters, who would then change whatever was necessary and deliver me a paper tape, and I'd start again.
So you had this wonderful team, it's almost like a pipeline process set up. Did this harken back to your days at IBM when you were doing the timeshare and the operating system work, that kind of teamwork?
Yeah, sort of. I think at IBM, I actually did all my punch cards and went to the 360 and did my own assemblies and did my own testing on. During periods of the day, I'd have my very own 360. It was like having a PC, except it was this huge mainframe.
And that was at home through a teletype terminal.
Well, once the operating system was built, we needed to test. And so we would have testing for all the features. And I could call in at home from my Selectric terminal. And we had little modems in big wooden boxes where you put the phone in, and I would actually play games and do all sorts of things from home. It was like having a home computer.
In 1968.
1968.
So in a sense that prepared you for the whole movement to the home computer revolution. You kind of had lived there already to some degree.
I had, and one of the first things I wrote was the 8 queens problem. How do you put 8 queens on a chessboard such that no queen can take another queen? And I wrote a program, PL1 program, to solve that problem. This was just fun.
So the spirit of fun, which certainly infused the homebrew club and that whole milieu, you were already into that. Did you ever attend a homebrew meeting? Question.
Yeah, actually there was a book called Fire in the Valley, and there's a picture in there of that has myself and my wife sitting in the background. And so, yeah, we went several times, just part of the crowd. My wife is a geek also. Today she teaches computer science at San Jose State, mainly Java.
At the meetings, certainly you may have run into Len at the meetings. It's a long time ago, but as you were working on BASICs, I know that Bill Gates talks about all the machines that they wrote BASICs for, and one of them was Kremenko. Did you encounter Microsoft or Bill at that time period, or Paul Allen? Was there a kind of a competitive in terms of producing BASICs for these machines?
We never actually crossed paths. After Apple DOS, I did a BASIC for Atari, and Atari had bought Microsoft BASIC, but they couldn't get it up and running in time. So they came to Shepardson for a BASIC for their Atari home computer. Later, I worked for Atari, and I met Bill Gates several times while working at Atari. But we never crossed paths in terms of BASICs.
And in that whole period of Apple's history, were you working physically at the Apple offices, or you were working at Shep's offices, or were you working at home?
I was mostly, on the DOS, I would work in Shep's office. My typical day would start about 1 o'clock, and I'd come in from 1 until about 5 or 6, and go out to dinner with my wife and maybe some of the people from Shep, and then come back to work about 10 or 11 o'clock and stay until about 3 a.m.
The real productive period.
Exactly.
Exactly.
And then I would leave a marked up listing, and Mike Peters would have a new tape for me when I came in the next day and start the process all over again.
Did some of the other early people, like it was, I believe, Mike Scott, the first president of Apple, or Daniel Kotke, did you encounter some of those early Apple people while you were there?
I encountered Mike Scott briefly. He never really got too involved with me. My main contacts at Apple were Woz and Jobs and Randy Wigington.
Randy.
Yeah, and I have nothing but admiration for Randy. He must have been 17, 18 years old at the time, and just a pure genius.
Yeah, Randy told us, we did an event years ago about Apple in the garage. We had Randy there and Woz and a panel of people who actually worked in the garage. And Randy rode his bike from school every day to be part of the Apple team then. And it's just fascinating to see how his staying power. And he was the one, I think, who commented about do not cross page boundary in the code. So he has a good solid memory of working on that.
Yeah, I think he and Woz actually developed that routine in a hotel at the Consumer Electronics Show.
Which routine was it?
The read-write track sector. you know, that's kind of the very core. It's the thing that reads and writes the disk. And everything evolves out from that.
So the where we see Woz's hand-drawn notes in that red felt pen,
Yeah.
it's him drawing out the read-write sector. And then there's some other documents which look like they're photocopies, but they're marked up, which show a more detailed sort of block version of the read-write sector.
Mm-hmm.
So that was done in over Christmas of 77, 78, you think?
I think so, yeah. It was for the Consumer Electronics
Mm.
Fair, which is in January, early January. And this was before I met them.
Mm.
But the read-write track sector that Woz and Wigington actually sit down and wrote it out in hand, and then they compiled it or assembled it by hand. And then they took the opcodes and entered them into the Apple II by hand. So they didn't use an assembler or anything else. It was all hand done.
And
Actually, the integer basic in the Apple II was done the same way. Woz did that whole thing by hand.
so in some of the other documents we see handwritten assembler.
Yeah.
That's done by Woz or Wigington?
By Woz,
By Woz.
yeah. And then when I did the DOS, I actually took that handwritten read-write track sector and put it on punch cards and included it as part of the DOS.
So that was the code that was delivered to you from them was that particular thing, but you had to key it in,
Right, it was just a piece of paper.
just a piece of paper.
Yeah. It's a small piece of code. I mean, it's probably no more than a page long.
And we hear, the stories about the North Star disk controller, which I have
Yes.
in my collection. I have an enormous board with at least 24 chips on it.
Uh-huh,
And then there's Woz's design with
7,
7 chips.
right.
And my understanding, maybe you can clarify, is that Woz didn't understand the design of a disk controller. He'd never really seen one, so he made something that just was elegant and simple and low chip count. So he used software to do a lot of things that these other companies were doing with hardware.
Uh-huh.
Can you comment on that?
Well, I know when I saw the design, I was familiar with the other disk controllers. And when I saw Woz's design, I was just blown away.
Mm.
I mean, it was so simple and so elegant. And the fact that he was doing it in software. I mean, a lot of the work that was done by those massive amounts of chips was done in a few lines of software.
Mm.
I mean, it was just pure genius.
Why would no other company have come up with such a
Because no other company had Woz.
right?
Like you say, he didn't know how to do it, and he created it in a way that is uniquely Woz.
So like the whole stepper motor control, everything was done through software.
Everything was done through software. Just amazing.
So the design that he and Randy delivered to you as code, as assembled code, so you kind of put that in as a block into your project.
Right.
Did that design stay pretty much the way it was?
Exactly.
Exactly.
It never changed during the time I worked on it.
So so your first delivery we note from the listings, was in early June of 78, right? Pretty much within a week of the target of that one-letter contract,
Uh-huh.
which to my mind, this is why I made the statement that it's the programmer's greatest generation. We talk about the World War II generation being a great generation. I think Tom Brokaw may have coined that term, but I think of that as just such an achievement. But of course, it's based on all your prior work and your preparation that you can sit down and just stream that out and make that delivery. The first delivery in June of 78, was that pretty much running and doing what they had planned to do? And following that, I know there's the whole summer of 78 all the way to the October final delivery. What characterized those sort of two phases of the project?
Well, when I began the project, what I had in mind was a file management system. This creates a structure whereby you can open, read, write, and close files. And that's what my goal was. And that's what I created to start with. And in order to use it, you had to write some code. If you had an assembly language program, you could write a little piece of code to fill in a control block and call my code, and you would get a file opened, you would get data from the file, you could put data into the file. But there was no commands. You had to do it yourself. And that's what I did. And that's what I delivered. Everything about the basic interface came after that. So when we talk about changing the specifications, my idea of the specification was a file management system that somebody else would write code to interface. It developed that I ended up writing the code to interface BASIC to that file management system. And one of the things that always disturbed me was I had a very clean interface to the file management system. There were control blocks and places you could call to do things. And it never really got published. And instead, what you saw was the basic interface.
So really, in some sense, the full power and efficiencies of the Apple II DOS could have been greater if they had published in what we now today call an application programming interface and allowed the developer to work that way rather than just through the BASIC interpreter.
Exactly. And I have encountered people in my life since then who disassembled the code and figured it out. And they ended up writing interfaces to it the way that I thought it should be done. And these were mainly game developers.
Yeah, the game developers always push those limits. They want to get at as close to the hardware as they can.
Exactly. Yeah, I just met a guy about a month ago, and we were reminiscing over it, and he was explaining how we could do 6502 assembly language in his head. So, I popped a question, what's an RTS? And he said 6-0. It's those guys and me, we just knew this stuff by heart.
That's why I think of you guys as the greatest generation.
Well, actually, I don't think that the engineers today are much different. I think they work just as hard, just as long hours, and have just as much drive. I know some people that work at Google, and these guys are no different.
Especially if they're building fundamental operating system, which they've had to. We've built and rebuilt operating systems now for 50 years, I guess, 55 years. Do you see, having built an operating system that got so widely used, and the numbers of copies of Apple II DOS out there were extraordinary, perhaps only exceeded by MS-DOS later. Have you seen, do you sense any sort of a trend in operating system development that's, have we come far, or are we still building just file systems?
Oh, we've come a long, long way. The disks are no longer in terms of kilobytes, they're in terms of terabytes. And the structure needed to create file systems under that, is immensely much more complicated. And what I created was a file management system. A true operating system has a lot of other components to it. Interfacing to other pieces of hardware, USB, the networks, screens, keyboards. So a true operating system is much, much more than what I did for Apple.
Do you see in the Apple II design, I mean, we know it had a fixed keyboard, unlike the S100 world where you had a lot of different keyboards, but it had the 10 slots that Woz had insisted on. So you had all these add-in boards in these slots. how did you have to build facilities to deal with those slots?
Actually, the design that was created had a pretty much set protocol for using those slots. When you plugged a card in, it would essentially know where it was, and you could address it that way. During some of my follow-on work with other people at Shep, with other companies, we used Apple IIs for example, I worked with a company that created a high-speed tape cassette, and they created their own plug-in board. I worked with another company that created a printer, and they had their own plug-in board. Another company developed a speech recognition thing, and they had their own board. So it was pretty easy for people to design and plug in boards.
In those projects, were you tempted or able to use your own direct interface to the file system in the DOS, or were you using BASIC?
Didn't really use any. I mean, for example, the cassette tape, it was an interface to drive that cassette tape. What the company wanted was they wanted something equivalent to read-write track sector for their cassette. They were going to do everything else. For the printer, it was mainly taking characters and pushing them out to the printer. So it was really not much involved in the DOS.
Was there a sense, I'm just sort of rolling the clock back to sort of the March, April, a quick question, when did you start working with Apple? What was your first day with Shep working on Apple projects? Do you recall, was it in 77 or 78?
I don't remember the exact day. It was probably no more than a month or two before the DOS contract.
So probably March of 78.
Yeah, probably.
As a company, when you sort of would go in, because it's just down the hall, it was in the same building at some point?
Yeah, it really wasn't a hall, but it was, the way the offices were arranged, each one had doors facing out into a mall. And so it was down the mall.
Down the mall, not down the hall.
Yeah, the mall is still there.
And that's how Shep met Jobs and Woz, because they were just physically co-located.
Exactly. And Shep had a reputation for having done microprocessor type stuff. So.
Right place at the right time.
Yeah, exactly.
So this is before they moved to Bandley Drive?
Yes.
So what was the address of that location?
I don't remember.
Somewhere in Cupertino.
Well, right now there is a Panera Bread and a Starbucks where Good Earth used to be. And if you go behind that, those same buildings are still there.
Gosh. And when you would go into the offices, you said there were 20 or so people there, what was the sense of it? What was the feel of the energy level, the commitment, the buzz, as we would call it?
I actually never went into the Apple offices. They were right over there, but I was probably 2-3 weeks into the DOS when they moved to Bandley Drive. And so most of the time I met with somebody who was over at Bandley Drive.
Was there a sense at the time of optimism, or the question that I have actually rolling back is, without a real operating system, a disk operating system, and without a real disk controller, perhaps, and you maybe could correct this, the Apple II sales would have been impacted by only having a cassette interface. So was that the case, and did you sense, and is there an urgency behind the DOS project?
Well, I got a real sense of urgency, but I really didn't get a lot of sense of what all else was going on at Apple. I was highly focused. And when I would come over, it would be to talk about the DOS or something, or BASIC. There were incidental contacts with people, but I really didn't get a reading of their morale.
Andy Hertzfeld has written about the creation of the operating system for the Mac and how Steve would just look at every step and he would be concerned about the boot times, shave a second off of here, etc. Was there any of that kind of interaction with Steve Jobs as a designer or as a project lead, or with Woz?
On the basic.
Okay.
Not so basic. Not so basic.
Not so basic.
Yeah, at Shepardson we called it nutso because it was growing so out of proportion. And my wife, Kathy O'Brien, was working on it with me. And one time we were over at Apple, and Steve was, we were complaining, whining, how big it was getting. And, Steve made some comment about it shouldn't be a problem. And my wife grabbed him by the collar, the shirt, pushed him against the wall, and tried to say, Steve, this is a problem. You need to listen. And he listened. At least he seemed to listen.
Gosh, my gosh. Shades of L.V. Ray Smith's confrontations with Steve at Pixar years later.
I hadn't heard about that.
Jeff had come from, I guess, University of California, San Diego, into the company, and his reasons for adding so much to the not so basic.
He was hired. My understanding was he was supposed to write the manual for Not So Basic. So as he was writing the manual, he was creating specs, and he was just adding all sorts of stuff. But his job was write the manual, and that was driving the project then.
So there must have been some conflict emerged between Jeff and Steve Jobs at that point.
If there was, I didn't see it. And Jeff's involvement in the DOS was fairly minor. He would suggest something here or there. And then I think he ended up being the guy that wrote the brochure, if you will, that came with the DOS.
With the DOS.
Yeah.
So this is a good segue into the delivery in October of '78 when it became an Apple product.
Uh-huh.
So a couple of common questions that I always hear and you've heard is, why was it a DOS 3.1? And how did the handover go? Who did it get handed over to, and what was the whole process?
My understanding of how it became 3.1 was when I would do a new version of the code, which was almost daily, I had a version number and I would increment it. I think it was started out at 0.01, and for each new increment it would go up. And by the time I delivered it, I think the listing had something like 3 something on it. And so somebody just decided to call it 3.1 or whatever. That's my understanding. The delivery, in one of the pieces of paper I gave you, there's a notes about a meeting. And this was coming to the completion date, or completion they were wanting to ship. And so there was some discussion about bugs and discussion about how it would be delivered. And we made a general agreement. I ended up having the cards read in text, pure text, and put on an Apple II disk for the cards for the program. And that was how it was delivered.
So that's how the actual textual 6502 assembly was delivered.
Exactly.
So the listings that you provide, these 2 listings, they were printed out off of the national machine?
Well, there was a line printer. I'm not sure what the brand of it was. A typical line printer of the day. Big box of paper and paper flowing through it.
So Apple wouldn't have been interested in getting such a listing if they could get it on a floppy.
Yeah, well, the floppy made it easy for them to then use it with a 6502 assembler.
So
And
did they reassemble? I guess at that point they were using the assemblers on Apple IIs.
yes, I delivered it to Randy and I forget his name now.
Was it Houston?
Yeah, Dick Houston.
Dick Houston.
And Dick Houston took it over. And so shortly after the meeting, I delivered a marked up listing and with some bug fixes and the disk with the source on it. And I was done. I really didn't have any contact with them after that. There had been discussion of my doing a verbal documentation. And I think once Dick Houston got into the listing, he understood pretty quickly how it was organized and took off running with it.
It sounds like a very, very clean project from your perspective.
Who had designed the structures on the disk for directories and for free space management? Was that you or
Yes.
was? And was there iteration and negotiation about
No, it was all designed by me. There was no discussion, no specs. I just did it. He, in his read-write track sector, determined the interleaving of the sectors on the disk so that there were optimal selection and rotation. But everything else was done by me.
In designing those structures, how much did you try to anticipate that disks would get bigger and track sizes would be different and so forth?
Not very much at all. You know, it was I was highly focused on the job ahead. So, you know, I had some focus, but I didn't really plan. What quickly followed the DOS was Atari coming in and wanting BASIC and a DOS for their home computer. So as soon as I turned the stuff over to Apple, I was off on Atari. And that was in October. And I delivered Atari a DOS and a BASIC in January.
Gosh, for what machine was that for, Paul?
This was the Atari 400, 800.
Mm-hmm. With the peanut butter keyboard?
The 400 had the peanut butter keyboard.
Gotcha.
The 800 had a regular keyboard.
So that was a cartridge-based machine.
Yes. And the BASIC went into a cartridge. And of course, the disk operating system was delivered on a disk.
So that was, in a sense, the Apple Annie, but from another company.
Exactly. Yeah. Yeah. Actually, parts of the BASIC were what I had been writing for Apple when they canceled Apple Annie.
So then this is the days before non-competes and all these sorts of things.
Right. Yeah. There were no lawyers involved in the contracts. So. And I didn't really use a whole lot of the code. As far as I had gotten on the BASIC was the text editor portion of it. And part of that is what went into the Atari BASIC.
So that's an amazing thing. In a single year, actually, you wrote 2 operating systems and delivered a full BASIC.
Well, and actually there was more than that. I wrote a C compiler for Krememco in the space of the same year.
An actual C compiler.
An actual C
Kernan
compiler.
and Ritchie.
Yes.
Yeah.
Yeah, took Whitesmith C on the PDP-11, wrote it in Whitesmith C, and it ran on the Z80.
So you wrote the compiler in C.
I wrote the compiler in C, yes.
And was that for the System 1?
It was for the Krememco, and I don't remember the model number. That's,
The one that had the hard drive?
yes.
Yeah,
Yeah.
so the heavy, incredibly heavy
Yeah,
units.
exactly.
Yeah.
Yeah, it was the 8-inch hard drives.
So that's all in 1978.
78, maybe 70, yeah. 79 at the latest, because I went to work for Atari in 79.
So you're no longer with Shep at that point, or?
Yeah, Shep kind of lost interest in his business. We had a really good period of time with the Atari contract and got huge bonuses because we delivered. It was something like $1,000 for every week early, and we were something like 15 weeks early. So got a huge bonus from them, and Shep got all enthusiastic about his business. He was going to sell hardware components, and then something happened. He just lost all interest, really wasn't interested in having employees anymore, and Atari made me an offer I couldn't refuse, so I went to work for Atari, and Kathy went back to work for SBC.
Did you or Shep ever think about taking stock in these companies rather than monetary payment?
There's an apocryphal story. Before Apple hired a new vice president of software engineering, Steve Jobs came over and offered Shep to become Apple software engineering for 25% of Apple. And Shep turned it down. He thought there was more money to be made independently. So, like I say, an apocryphal story.
So after Atari, how long were you with Atari?
About 2-3 years.
So during that entire incredible growth period when Space Invaders had come out and things
Exactly.
like that.
Yeah. Yeah, I worked in the home computer division. I was the manager of the home computer division, software. And I left Atari to go to work for Fox Video Games. I was director of engineering there. And so worked on a lot of games, mainly from a management standpoint. At Fox, we did games for all sorts of home computers at the time. The TI, the Commodore, Apple. We would turn out the same game for each machine.
That's an interesting challenge. I mean, given different CPUs and
Yeah.
different cartridge formats or disk formats.
Uh-huh.
Yeah, complex.
Yeah, it was an interesting time at Fox. Fox considered this yet another project. You know, like they have a movie that's a project. Well, this was one of their projects, and it wasn't making money, so they shut it down.
Kind of in some similar sense as Lucas and Lucasfilm and Lucas Games,
Exactly.
etc.
Yeah.
So that would have been about 82, 83 that.
Yeah, about 82. And trying to think, it was around 1984, 1985, I joined a startup company doing voicemail and created an entire voicemail system with myself and another guy.
Oh, amazing. Digital voicemail.
Digital voicemail, yes. Yeah.
And that, how did that company go?
The company went on for a number of years into the early 90s, finally went under. A company called Voices. And I went from Voices to Logitech and was director of software engineering there. And then in the mid-90s, I got enthusiasm for digital cameras and persuaded Logitech to come out with the first consumer digital camera. And this was 94, 95.
Was that, which model was that?
It was called the Logitech Photoman. And then Logitech and Kodak worked together. And we created the Kodak DC-40, which was Kodak's first commercial digital camera, consumer digital camera. So I was really enthused about digital cameras at the time.
You weren't wrong.
No, I wasn't. Our dream at the time was a camera in every pocket, and that's what we got.
That's what we have.
And in the late 90s, I worked for a company that had an operating system, a digital camera operating system. And we were interfacing cell phones to cameras. And so it was kind of the lead into what we have today.
So in some sense, your work at IBM and then your work at Apple and Atari and digital voicemail, they were all, and then the cameras, it was like small operating systems doing efficient things with files
Yes.
in robust ways
Hmm.
that interface with a few devices, but the effort led to a widespread propagation of these very, very small but effective operating systems.
Yeah, in a sense, they were all operating systems. Even voicemail was an operating
It's an
system,
operating system.
because we had to organize a disk for the various users and their messages and so forth.
This is a through line theme through all of your work here.
Yeah, I never thought about it that way, but that's true.
And since 2000,
I retired in 2000, and about 3 years ago, I got interested in doing software engineering again, and I created a BASIC that runs on Android. And this BASIC now has about 50,000 downloads, and I released it under a GPL GNU license, and so now I have a team of developers working on it, and also have a full-time, or not a full-time, a volunteer manual editor working on the 120-page manual. So once again, into the computer world.
does it implement all the features that Jeff wanted in Not So Basic?
Oh, it implements all those and much, much more. I mean, it touches just about every API in the Android. You can manipulate pictures, you can send and receive pictures, you can do FTP, all sorts of networking stuff. Whatever you can think of that you could do it on Android, you can write a program in BASIC to do.
So 35 years ago, sitting there down the hall from Apple, building this file system OS that connected with a BASIC, if you could have seen yourself in 2010 or 11, whenever this project started, doing a BASIC for another device that has really good access to its file system and all of its services, but it's held in your hand and it has gigabytes of memory and it's connected to a worldwide wireless network and can play video and all these sorts of things. Did you ever cast your mind forward, ever dream that things would evolve so incredibly in that 35 years?
Well, I certainly had an idea that home computing would evolve quickly. I don't think I ever really forecasted the smartphone or the tablet.
Mm-hmm.
But if the me came forward to today, I wouldn't be surprised, if you will.
Mm-hmm.
Google and Android Android's an operating system, and I really haven't delved into it much because I use all their APIs, but I certainly have a lot of empathy for it.
Mm-hmm.
And the issues that the Google engineers have.
I'm hoping that this interview at some point will be online and available, and that some engineer, like a Google engineer that's younger, will hear your story and say, hey, I'm working along the same lines, the same lineage, the same thinking, and feel connected to computer history, which of course is why we're all so passionate about this.
Yeah, there was recently a show on TV, I think it was called Silicon Valley. It was kind of a reality show, and some guys and girls working in Silicon Valley. And my watching the show and the way those guys worked, it was really no different than the way we worked back in the 70s.
Mm-hmm.
There's a new generation of very small computers built out of Arduinos and Raspberry Pis.
Yes.
Have you considered working with them and porting some of your software to it?
Actually, my current interest is in amateur radio. And there's something called software-defined radio, where all the the capacitors and coils and all the stuff that used to be in a big radio, tuned circuits and so forth, are now eliminated. And you essentially capture the entire RF spectrum and digitize it and then send it to a computer to work on. And so my interest is in software-defined radio, digital signal processing.
I think there was such an incredible crossover between the ham community and the early personal computer community. There's a note in the second issue of Byte in October of 1975, an angry letter sent to the editor, I guess it was Carl Helmers, saying, "Why did you turn the perfectly good amateur radio magazine into this computer thing?"
Yeah.
And then in Altair Notes, there's the second edition of the Altair Notes is someone connected a ham radio system, A to D, whole converter and everything, to be able to send mail wirelessly in New Mexico. And they created a mailbox application in the summer of '76.
Amazing.
From S100 machines. And so that ham computer connection is ever so strong, the same kind of thinking, same kind of people. This leads to another technical question I wanted to ask is, what was specifically done in the DOS to support access to what we call now as a frame buffer or screen buffer to allow gamers to write to the color display of the Apple II?
Well, there was nothing in the DOS that did that. That was all in Steve Wozniak's small. He had an operating system of sorts for interfacing the screen memory and for the plug-in cards and so forth. So, I was saying that what I did wasn't really a DOS, it was a file management system. The other part that would make a DOS is something that Woz did in the Apple II ROM.
So really, in some sense, the Apple DOS is a collaboration between yourself, Randy, Woz. You put it all together, and it was the DOS.
Yeah, like I say, my goal was to create a file management system. And then on top of that, we added the command interface, the basic. You could type in load in basic, and it would end up going to load a file. Those were all add-ons, and the specs for that were mainly done between Randy and I, and with a bit of Jeff Raskins and a bit of Woz.
So that there's a letter in June of '78 that talks about a couple of changes that are needed, and that they'll be done by tomorrow, and it's for $500, which is kind of an interesting, dollars per line of code kind of a thing. But so that was happening kind of after your first delivery, the first listing, those kind of add-ons with Randy and adding that stuff to finish.
Somebody would want things, and I would usually write it down on a piece of paper and then take it to Shep, and he would put a price on it.
Okay.
And that's the way it worked.
That's interesting. And so how many, I would gather there would be a number of Apple IIs over at Apple in Bandley Drive that would be running the DOS. A number of people kind of cranking away on it while you were writing it, or was it all?
I really don't know. I would take it over and deliver it to them, and they would come back with something. There were not many people working on DOS at Apple during the time I was working on it. Randy was probably the only one that was working on it full time. Dick Houston hadn't been hired yet. And Jeff Raskins kind of dabbled in it, but that was about it.
It's interesting because you would think it'd be a core focus of the company.
It was, but there wasn't much of a company there. Like I say, Jobs had offered Shep to become the software engineering department of Apple. So, we would have been it.
So the rolling, and this is when you were no longer really in contact with them, the VisiCalc team building VisiCalc using the DOS. I would assume they built it in an assembler.
I really don't know. I didn't have contact with any of those people.
them. But of course that led to the taking off of the Apple as a true tool
Yes.
for the businessman and the small businesses.
I think it led to the taking off of personal computers,
Mm.
home computers.
So this will be a follow-up interview where we try to figure out, or we ask them, how did you fit your 2K spreadsheet application
Yeah.
into this framework
Mhm.
efficiently? Because was it built in BASIC? I don't know.
I assume it was done in assembly language.
Yeah.
I mean, if I were doing it, I would do it in assembly language.
So if it was built in assembly language, how would they interface with your file system without documented API?
They, like the game developers, they probably figured it out.
They reverse engineered it.
Yeah, well, there was a book called Inside AppleDOS, and I think Inside AppleDOS figured it out and explained it.
Why do you think Apple didn't release that API documentation?
I really don't know. I mean, I asked them to. I said I volunteered to write it up, and their response was something that, you know, we're busy. So, but like I say, people figured it out.
Years later, when people would talk about how they started, you know, their first love was an Apple II,
Uh-huh.
things like this, and how they built businesses on it and whatnot, would you mention your role in the history, or would you just stay quiet and have a smile on your face that you had a...
Well, I usually mention my role in it,
Mm-hmm.
and usually get a "oh wow," and
Mm-hmm. You collected "oh wow" mugs.
yeah, exactly. Yeah, I recently sponsored a block party for my neighborhood, and as part of it, I sent around flyers, and some of the people Googled me, and after Googling me, you know, they'd say, "Well, are you the guy?" And so it's been fun.
Did you have an Apple II sitting at home and throughout the 80s, or?
No, actually, I moved on. I loaned my Apple II to somebody who was starting a company. I actually had an Apple II and 2 disk drives, serial number 2 and serial number 3. And the person that I loaned them to sent them back to Apple for refurbishing, and they came back generic disk drives, different serial numbers.
So they melted into wherever.
Yeah, they're either somebody in Apple, some engineers got in their personal collection, or it's went into the junkyard.
Mm-hmm. In some, I've been calling this little project of ours how Apple booted up
Uh-huh.
as a company, in the sense that it needed a software platform to allow developer community to emerge. Does that seem like a fair, that whole period and this whole project really helped Apple to boot up as a company?
Oh, I really think so. I think the Apple II was a wonderful machine, but without a mass storage device, you know, it wasn't going to go anywhere. And having disks on it meant a world of difference. I mean, it was the catalyst that, like, created VisiCalc, and VisiCalc created the revolution, I think.
Mm-hmm. Mm-hmm.
So it just didn't boot up Apple. I think it booted up the home computer industry.
Interesting. Yeah, certainly working on Apple IIs back in the day, I always used to appreciate that little sound that would occur, and the red light would go on, and my Apple would come alive, and then of course the DOS would be there, and then it would go to the other drive for my applications, and that subtle stepper motor sound or whatever it is, plus that red light, always gave me a sense of reassurance that my computing world was coming alive. And never imagined I would meet the men that worked on that little sound.
Are you talking about the 1,000 cycle note? The beep?
Okay, that's right. There was a beep as well.
Yeah, that was in Wozniak's ROM. You know, whenever Apple would beep, it would make that 1,000 cycle note.
So there was the beep and then followed by a sector read operation.
Mm-hmm.
It was very distinctive.
Yeah,
Yeah.
yeah. You could hear the stepper motors going, and
We recently had Steve Wozniak over to my collection at the DigiBarn Computer
Uh-huh.
Museum, and we put in, original, I think it was serial number 400 machines early on, ones that were built by Dan Kottke at Apple at Bandley Drive, and
mm-hmm.
we recorded everything. We took the video out of the machine so we could get that sound specifically recorded, and that floppy drive painted a picture of Woz's face on the screen as an invitation to the US Festival.
Oh wow.
The little signature of Woz that
Uh-huh.
came out, and we had Woz, was delighted to see that it all was working and had forgotten about his floppy-based invitation that he had sent out to all these people.
Hmm. Yeah, Woz is quite a guy. He really was.
Was so as a human being, we all know and love him, and what was some of your impressions of him?
It was interesting. My interaction to him was mainly technical and on the project. You know, we went to lunch together a couple of times at the Good Earth. I remember we had a discussion about salary, and I was getting paid, I think it was something like $35,000. He was getting $25,000. And sometimes people ask me why I didn't go to work for Apple. I was making a lot more money as a consultant.
Interesting. Did Woz talk about his life at Apple, or mainly it was technical discussions that you would have with him?
Mainly technical. I mean, there was some discussion about his wife, or ex-wife, as I recall. She was known as the condo queen. But not a whole lot of personal stuff, no.
Mm-hmm. Mm-hmm.
We were busy people.
We were busy people. Would you look over listings when you went to lunch, or?
No. No, it was mainly discussing, what was coming, so forth. So I don't think anybody ever looked at my listing at Apple until I gave that final one to them. Just we were just moving too fast, and they didn't have personnel who had the time.
So in truth, Shep and you guys were the software division, in truth.
In truth, yeah,
Hmm.
very much so. Cannot discount Randy. I mean, Randy was the one that made Microsoft Basic work on the Apple II, and that was no small task. So he was, if anybody was software engineering at Apple, it was Randy.
And a completely self-taught man, and
Oh,
you're
yeah.
a young man, and
Yeah.
yeah. And you and Randy would go to lunch and have technical conversations.
Not very often, no. No, it was, maybe once or twice. It was Randy and Steve Jobs and Woz. We went to lunch at Good Earth.
That must have been an interesting table to sit around in retrospect.
Yeah.
Yeah.
I don't know if you're familiar with the Good Earth. If it's it's kind of like a Whole Foods.
Mm-hmm. And
Yeah.
early kind of, or almost
Yeah.
like an organic.
Yeah, exactly.
Yeah.
A lot of vegetarian stuff and vegetable drinks.
Famous for their tea.
Tea, yes. My wife still gets their tea.
So do you recall sitting around the table with most of Apple at one point? Do you recall any of those conversations?
It never really happened. Like I say, once or twice coincidentally, and I don't even remember much of the conversation. We were in there for the business.
You were heads down, you had deliverables to make.
Right,
and-
exactly. The same thing when I was working with Atari. It was very little discussion about. There was a lot of politics going on at Atari at the time when I was working as a consultant for them, and I just didn't get involved. Heads down, working.
That sounds like a life strategy that actually is a fairly sensible advice to anyone.
Well, I did contracting for many, many years, and among us contractors, one of the things we like is we didn't get involved in politics in the company. We did the job that was asked for us, and if there were any other issues, that wasn't our problem.
I think in some sense the brackets around all of this is simplicity, or KISS, keep it simple,
Right.
stupid, or whatever we call it.
And that was diametrically opposed to my being a engineering manager, where I was the politics.
So you ended up having to carry the load of the politics to, in a sense, protect the people that were doing the real engineering down the road.
Exactly. Very much so.
These are just the last few questions, and Lynn, you may have some too, but did you ever in the Valley visit places like Xerox PARC or SRI, or go to talks, Stanford talks, or?
Not really. I've been to a few talks here at the Computer History Museum, but most of the time I've just been busy.
And when you worked at Shep, where were you living in Cupertino, or you?
Yeah, actually, my wife and I bought a house in West San Jose, near De Anza Boulevard, and we still live there.
Same house.
Same house.
So from the mid-70s.
79 is when we bought the house.
Simplicity again.
Yes.
Yes.
Yeah, we bought it because it was close to Shep, close to Apple. And then I ended up spending almost 10 years at Logitech, which is in Fremont.
So you could just go up that way.
Go up that way on my motorcycle.
On your motorcycle?
Yeah.
Did you use your motorcycle going to Shep?
No, I didn't start riding until the mid-80s. And then I quit riding in the late 90s.
What's your advice for young people today who want to do the kind of successful projects that you did? What languages should they learn? What experiences should they have?
Well, one of the interesting things is, for example, I have my son-in-law, brother, is the vice president of engineering at a company called ITSE. And he only has a high school education.
In New York? In Brooklyn?
In New York, yes.
Yeah.
And
My nephew works there.
okay.
Yeah.
And I think there are a number of very brilliant kids who have never been to college or have done very little college. And they're also the opposite. I mean, you've got the founders of Google who were very much academics. But I would say kids who have a dream, just go for it. You don't necessarily need that college degree.
Do you think young engineers need to understand digital logic and machine language programming, or do they do everything with high-functioning boards and C++?
I think today they do everything with high-level programming. I mean, even things like digital signal processing is done with a high-level language now. The only people that write low-level language, I don't know, I suppose if you had a very small ROM, you might do some assembly language, but I doubt if much of anything is done in it.
Maybe embedded systems and.
I think even embedded systems are compiled code now.
Do you think there's a danger that people who work only at high levels will not understand how the machine really works?
I think you have to understand it in order to drive it. something like an embedded controller. You may work in a high-level language, but you have to understand the electrical interfaces because you're driving them, you're using them. I think there's object-oriented programming, and that has led to a lot of reusing of code. For example, today if you want to do a sort, almost nobody writes a sort. They just reuse somebody else's sort. And my experience with working on Android is there's just lots of API calls there, and we use those. And I think the same thing is true even for Arduino development. There's a library of routines. If you want to talk to RS-232, there's an RS-232 routine that you call. You don't actually go out and drive data terminal ready and RTS and so forth.
An interesting thought just occurred. As you know, we've obtained permission from Apple to release the source publicly. And we're going to be, it's now been keyed in, at least the October 78 version, and we'll be attempting an assembly of the source. Any advice for the assembler, future assembler, and people working on that source code?
Well, as I said, the assembler that used to create this was an adaptation of an assembler that Shep wrote for the IMP16. And you're going to find opcodes that are different and various directives that are different. And so it's not going to be, you just load a 6502 assembler and run it. It's going to be some changes have to be made.
So they'll have to write some macros to represent those?
Well, I don't think they'll have to be macros. It's just doing it in standard 6502 assembly language is different. It's just finding the different opcodes or directives that do the same thing.
And a follow-on question to that, if we manage, if a team or someone out there manages to assemble it and say run it in emulation, well, we would obviously try to run it on an Apple II to see if we're getting it to run. And a group emerges around extending somehow, because you can emulate anything on the net. So there could potentially be a growth path for this piece of code. What do you think we could, that you would have wanted to do with the Apple II DOS that never got done? Where do you think it could go from here?
Well, if I look at what is available today for storage, just looking at it from a file management standpoint, a file management system of today is just so totally different, so complex. You have an immense amount of data sectors available, and organizing that and so forth is just a vastly different job. I mean, it's like a lawnmower engine as opposed to a V12 Ferrari. It's just so totally different.
So somebody extending this DOS and calling it, giving it a new name, because if it's released, it could have a future life. What on earth could it be used for?
At Shepardson, we had this crazy idea of taking the DOS and Apple disk drives and making a generic product for 6502 devices. We were going to do it for the KIM-1, the SIM-1, the Commodore PET, and I actually designed a board that would interface the KIM-1 to the Apple II disk drives. And I had wrote a front end to the file management system that we called CP/A. It was a command line thing just like CPM was. We actually published a brochure, and Digital Research told us to cease and desist.
An early example of a legal...
Yeah.
Yeah.
But so we were going to do that, but then Shepardson, like I said, lost interest.
Hmm. These are sort of tail end questions, but the command line interface, deciding that the word catalog would list the files, for example.
Mm-hmm.
Did you write all that? The command line interpreter and what the commands would be
For BASIC, yes.
for BASIC,
Yeah. I mean, not for BASIC, for Apple DOS.
for Apple DOS?
Yeah.
So the word catalog, we know when DOS came out, CPM, I guess, used dir,
Mm-hmm.
and DOS used dir, different drive letters. But when you chose those names, what was your inspiration for using a name like catalog, for example? Run's obvious, but
I think IBM. You know, as I recall, we used the term cat at IBM.
interesting.
And in the Call 370 time sharing system,
Mm-hmm.
if you wanted a catalog of your disks, you typed in cat. So it was pretty much lifted from Call 370.
So you could put in the word catalog or just the shorter
Right.
cat.
Yeah.
Any other commands you remember that came from that world?
I'd have to look over it. I mean, they're in the listing.
Mm.
In the Apple DOS listing, you can find all the commands that went through BASIC. So I'm sure there were some. A lot of the terminology that are used in the listing came from IBM operating system. Things like the VTOC, the volume table of contents.
Mm.
This is what you'd call the directory today.
Mm-hmm.
And the sector allocation map, things like that, all came from terminology that I used at IBM.
So in a way, this is a very early IBM Apple connection.
Yes, very early.
Very early.
Yeah.
You know, and MS-DOS being a later, an IBM PC. When IBM got into the hardware game.
Yeah, well, MS-DOS was really a derivative of CPM.
Mm.
It was a derivative for the 16-bit processor that was done not by Microsoft, but by somebody else who Microsoft bought it from.
I think by Patterson for the Seattle Computer Products Gazelle machine.
Yeah, okay.
Mm.
And so it really had a different evolutionary path than Apple DOS.
And IBM was building the 5120s and 5100s in the period.
Mm-hmm.
But I guess the IBM PC was a couple of years in the future.
Yeah, I remember wanting a 5120,
Mm-hmm.
but they were very expensive at the time. I think it was, what, $5,000,
Yeah.
something like that.
Did you look at other languages like APL that would have been available for a machine like that?
I actually wrote a Prolog interpreter that ran on the Atari.
Hmm.
So in my various jobs, like I have written many different compilers that do things other than compile computer languages, network connections, things like that.
So that's really your other side of your career, was compiling all kinds of codes to other codes.
Yeah, I was fascinated in the compiling, assembly, language translation kind of thing.
Hmm.
And so I did a lot of that.
Of course, it became protocol conversions later with the net coming out in TCP/IP and all that.
Yeah.
That's sort of real-time compilation. And one of the things that amazes me is the amount that's done through script, through just interpreted script today.
Mm-hmm.
Executing script like JavaScript is perhaps more code being run that way than compiled code.
Yeah, and I think, Java is compiled into a bytecode. And my wife teaches Java, JavaScript, so I get to hear a lot about it.
Mm-hmm.
The follow-on machine to the Apple II was the ill-fated Apple III, for which Apple was designing their own SOS, sophisticated operating system.
Mm-hmm.
Did you or Shepardson have any involvement in that?
No, and I actually did not know about the Apple III until just last weekend. I was at a ham flea market, and there was an Apple III there. And that was the first time in my memory, I'd ever heard of it. And so I was chatting with the guy that was telling me about it, and he was saying they had this thing called applesauce. And, that was the first I heard of it.
There was another lost to history project in Apple. When Lisa was being developed, there was a effort to make a sort of a visual operating system. They call it Mona. And I've only heard one reference to this thing that was being built because there was ever this effort on the Apple II community to bring themselves into the graphical world. And I guess there was that machine in the mid-'80s which could boot into Apple II DOS or into some kind of a graphical mouse-based interface. It was very kludgy. But that was that envy of that future bitmapped graphic world.
Didn't Bill Atkinson work on Mona?
Oh, interesting.
I seem to recall hearing the word from him.
From Bill?
Yeah.
Interesting. Mona and Lisa.
Yeah. Like I said, our offices were right next to each other, and we would both go outside to smoke.
There's another artifact in my collection, which is a sleeve of chips that say Brooklyn. And it's 16-bit 6502s.
Oh, really?
Prototype 16-bit that was this machine that never saw the light of day called the Brooklyn, which was meant to bridge between those two worlds.
Did you say 16-bit?
16-bit.
Yeah, okay. I think I'd heard of a 16-bit 6502. The 6502 was what we would call a reduced architecture today. It was a very simple architecture as opposed to like the 8080 or the 68000.
And I believe Woz chose the chip just because of cost.
Yeah.
Yeah.
It was quite a remarkable chip. Commodore chose it. Apple chose it.
And then the whole history of MOS and all of that, Commodore and taking it over. And there's another piece of code that Woz provided called Sweet 16, which I guess, what did you know about Sweet 16?
Oh, yes. Yeah, well, I'm trying to think. I had done something with Sweet 16, but I don't recall. I think I may have ported it to the Apple or to the Atari.
Interesting. So it was a 16-bit assembler?
Yeah. It was 16-bit math.
Wow. Okay. I showed him, we actually had very faded copies of handwritten listings of this, and the same fellow who may assemble your source had hand-drawn and filled in and completed so you could actually see it. And I presented it actually in this building about 7 years ago. We had an event, Apple's 30th birthday party, and I presented this to Woz, and he looked and his eyes teared up. He said, "Sweet 16, I haven't seen this in 30 years."
Yeah.
So this is the kind of emotional connection that someone like him has to code. I don't suppose you have such an emotional connection to your code, or do you?
Well, just a little while ago, we were looking over this listing, and it's been the first time I'd looked at it in decades. And I started getting flooded with memories of the time, and I could actually smell the environment that I was in when I was creating this.
Interesting.
In the lab at Shepherdson's, and just picturing this whole thing. And
so these artifacts are like memory palaces.
yeah, it took me back when my wife and I were both working at Shepardson, and we would work for days on end, and then in the middle of the week we'd take like Tuesday and Wednesday or Wednesday and Thursday off and go skiing, when the ski slopes were empty. And it was the kind of thing that we could do.
It was a new freedom, a new lifestyle actually was being invented then, instead of the 9-to-5 lifestyle. It must have been appealing to be the contractor that had such, you had flex time. You could work any 100-hour week you chose.
Exactly. And we did, and we took great advantage of it. You know, you were asking about Shep earlier. One of the things that I do remember about him is he was very generous. And there was a time when he took Kathy and I, he and his wife took Kathy and I to Las Vegas for the CES show. And he just paid our entire way, took us out to dinner, took us to shows. And at the completion of the Atari Basic project, he took us skiing to a ski place in Colorado. We went skiing for an entire week. He paid for the entire trip, bought all the meals, bought our lift tickets. Aspen, Colorado.
Mm-hmm.
And often would take us out to very expensive dinners. And there was a place called the Town Oak over in Sunnyvale. It was a bar. And I had all my reviews in the Town Oak. We'd go over there about noon, and we'd start drinking, and I would get drunk and then sober, and then drunk and then sober. And about midnight, I'd have to call my wife and say, "Come pick me up," because I didn't want to ride home with Shep, who was drunk. But spent quite a bit of time at Town Oak and met a lot of people in Silicon Valley. Met Chuck Simone. He was, I don't know why he was at the Town Oak, but just a lot of people.
Yeah, Chuck was at Xerox PARC, at least until about, I guess, 82 or so.
Mm-hmm.
Yeah.
Yeah, I think, okay.
Is there any other, anything we've left out or you've left out or that's coming in from the ether we should put on tape?
Well, I think I have very much enjoyed my life as a software engineer in Silicon Valley and all the different companies I've worked on, all the different things I've worked on. And I'm proud to be part of Apple DOS, but I'd be just as happy if I'd worked on other things that were less well known. I'm just glad to have been a part of it.
Well, you know, it's in some sense this is a spin of a roulette wheel in our careers, and chips fall in different slots, and you put chips in so many slots in all the projects you've done, which are impressive and wonderful. And of course, one of your chips fell in the Apple slot, and Apple went on through the lottery of life to become well known. But certainly, all of your other projects, you know, for us computer historians, are equally valuable in terms of the history and understanding how it all fits together.
Yeah, and my own personal evaluation is that the work I did for Atari, the Atari Basic and DOS, was much more monumental than the work I did for Apple, because it was so much in such a short time.
And it got launched on all these different machines and cartridge format and different formats.
Yeah, exactly.
Exactly. And then, of course, we work on digital cameras.
Mm-hmm.
I mean, that's pretty monumental.
Yeah, exactly, yeah. It's been a fun life.
Yeah. Well, thank you, Paul. This has been a total delight.
Well, thank you, Bruce.
I'm glad that you one day decided to ship a box of documents, because, and apologies for it taking, finishing a PhD and whatnot, and I think it was back in November of 2011 I finally opened the box and realized how important this was, and decided to make that the focus of, in my computer history project. This is the project of this year. And thank you for being so willing to help understand that and then unfold this whole history. It's been an incredible delight.
Well, I'm very pleased with what you've done with it. I'm glad I was able to get it to you.
And I think now it has a home here at the Computer History Museum, and it will have a life out there in the world. And perhaps at some point in the next year or two, we might end up doing some kind of an event for the public. I just know I haven't really thought about it much, but
That would be fun.
it'd be fun to do. And there's several people who've expressed an interest. the VisiCalc guys, certainly has, and Randy was interested, and
Mm-hmm.
just to come together and talk about the software that made the booting up of Apple.
Yeah, I'd be really interested in talking to Dick Houston because he took on my work and had to maintain it and so forth for many years. And I'd like to know what his experiences were. And
So that might be a good follow-on
Yeah.
interview to bookend on this one.
mm-hmm.
As we
Exactly.
chart this history.
Yeah. Okay, well, what I have here is a listing, a line printer listing of the Apple DOS as it was delivered to Apple on October of 1978. And one of the first things I notice here, this code starts off with relocation of the DOS. So DOS was actually written to be relocatable, and it would load into the lower 16K of the Apple II, and then it would look around and find out how much memory was actually there, and then relocate up to the highest memory location. So this was the first thing it did every time it booted. And this small section of code here is the code that figures out where it is, where it needs to be, and then does the relocation. And the assembly code in 6502 had hard-coded addresses in them. So if you were branching or loading from a location, it would branch or load from a location. So the relocator had to change all those addresses as it relocated. And so it took a tricky bit of coding to write the relocator. And so I'm just looking through it and remembering doing that. And being shocked when Apple said that I had to do it. This was not part of the spec, but you want me to relocate the code? I mean, that's pretty heavy stuff.
Well, there's a comment in there that I like. It says, if it ain't there, it's right in the first few pages.
If it ain't there,
It's looking for something that
it's looking for.
I always wanted to ask you about it. It's actually right down here. Get how long. If it ain't, then ain't 3, then don't relocate.
Yeah, okay. That's 3-byte operators. There was an operator and an address. If it wasn't a 3-byte type operator code, then the following 2 bytes didn't need to be relocated. So that's what that was all about. Figuring out it had an address. One of the interesting things, for example, when you type in a command in Apple, you type in cat or load, the code would have a lookup table. So it would be scanning and it would find in this table the word like cat. And then it would take the index of that word. And there was a vector table. So it would take that index, look into the vector table, and then go to the location where the code for that was. And there was no such way of doing that in 6502. But there was a tricky way of doing it. There was, if you had an address in a register, you could do what's called return from subroutine, RTS. And if you did the RTS, it would go to the address in the register. So the vector table consisted of a bunch of addresses that I'd load into a register, load an address, and then do an RTS. And that would be a vector to the routine. Just remembering creating that, how clever I thought I was. Then it turns out Woz had done that.
Woz and Wigginton noted that you shouldn't go over page boundaries on their handwritten listings. What was that about?
Well, this was just in the read-write track sector, and timing was very critical. They knew exactly the clock speed of the Apple II 6502, and you have this spinning thing that you have to be there exactly at the right time for. And if an instruction went over a page boundary, it would add an extra cycle, clock cycle, and that would mess up the timing. And a page is a 256 byte page section. So the instructions had to stay within a page in these particular routines, or else it wouldn't read the disk right.
At the end of the list, you have an enormous symbol table. Is that your VLOC table?
No, this is part of the assembler. So, for example, there's a variable called TSR, and this tells me every line where TSR is used. It's mainly if I'm debugging and want to know where a variable is used, I can come here and find it, rather than having to look through the whole listing. So that's an artifact, a good artifact of the assembler.
Were you using a line editor to write the code?
No, we had punch cards.
Oh, it's all punch card, of course.
It was all in punch cards, and the way things would get changed is I would mark up a listing and hand it to a guy named Mike Peters, who would go to key punch and do all the stuff and put it in the deck, and then run it through the computer that did the assembly. So it was all key punch. We could only dream of text editors at that point.
No paper tapes survived, presumably, of
I would assume not. No. There was no reason to keep them around. Shepardson actually had a business of duplicating paper tapes. There were, at the time, a lot of paper tapes were used in the valley. So he would essentially provide a service, duplicating your tapes, or copying paper tapes onto Mylar tapes, so they were more durable.
So perhaps Bill Gates' famous angry letter to hobbyists, where he complains about people duplicating his basic. Maybe Shep did a few of those.
That would be possible. I certainly remember that letter very much. Bill Gates complaining about not getting enough money for his basic. It's kind of interesting in retrospect.
Is there anything else you think is worth mentioning?
Anything in these documents? That's
Hold up the disk controller and
oh, the disk controller, of course, yeah. The before and after. So before, we used to have to do this,
Cassette tapes.
cassette tapes, and then after, we get to a disk.
Well, this controller, this is the what I call famous disk controller with 7 integrated circuits. And the disk controllers at the time had probably over 100 circuits on them. And what those 100 circuits was doing is now being done by Wozniak in software. So one of these, this one here is a state machine. Basically, it did state transitions. You would put in a state and it would give you output another state. And his code would step through the state machine. It was genius, just genius.
In fact, the state machine is in here. The actual state machine itself is described. There it is. I'm fortunate to open the right page. So there we go.
Yeah, the state machine was a 256 byte ROM, and if you would put an address in and get some data out, and this was his state machine. This was what was in those 256 bytes. It was quite amazing. I still don't know how he came up with the idea.
Yeah, here's some of your handwriting and some of Woz's handwriting.
Yeah, this was this page was my handwritten instructions that I got verbally from Woz on how to do a boot. So when you put the disk in and wanted to boot, this is what the steps I needed to go through to boot up. And very interesting. I don't quite understand my notes now. I'm sure I did at the time.
And so this is Woz's handwriting on the read-write sector.
I guess this is just a short map of the code in his read-write track sector of the various portions of it. There's read, there's write a sector, read a sector. And this is getting the address of a sector. So you've got this disk spinning, and you want to know the address of what's under the head. And this gives you that address. This is read-write track sector. And he had, the disk drive had stepper motors. And this routine here controlled the stepper motors. So usually this was done in hardware. He did it in software. He is actually driving the stepper motor step by step by step. And a stepper motor, you just don't drive it, you have to accelerate it because there's momentum involved. So you start off and you accelerate it until it gets to the location you want. And this was all in this little routine.
So here these are the actual opcodes.
Okay, this is just part of the thing. Now, he has a full listing in here, done by hand. This is, it's a block diagram, essentially, of the thing that's on his card. These are the 7 ICs and how they are wired together. I just call it schematic. And very simple, very elegant.
And Bill Fernandez, I wrote to him about this, that he had created this one.
Was Bill Fernandez the hardware engineer?
Yeah, and here's another piece from him that was in your collection. December '77, so this is before the Woz produced the floppy drive. So I wasn't quite sure what these were going to.
Well, I'd like to say a word or two about Bill, because he was an analog engineer that was just as much of a genius as Wozniak. This is the, he had if you open up a disk drive, inside there's a board, and there are ICs on the board. If you look at the standard disk drive of the era, it was just chock full of stuff. Resistors and transistors and capacitors and transistors. I mean, it was just end to end filled. And Fernandez did the analog part that went on the drive. And if you look at it, there's almost nothing there. I mean, it's sparsely populated. It's as sparsely populated as Woz's control card. And in my mind, it took a genius to create an analog circuit that could be done in so few parts. And of course, what this did for Apple was everybody else, when they made a disk drive with the controller, had to spend a huge amount of money to get these things into production. Apple could do it, very, very cheaply and sell it for the same thing that they were selling it for. So it was a huge profit margin for Apple, and just the genius. When I was working, I told you we were making disk drives for other 6502 machines. And when I was working on the project, I needed to convert +5 volts to -5 volts. And I called several electronic engineers and asked them, and they recommended off-the-shelf parts, and they had a very complex solution. I walked over and talked to Bill Fernandez, and he sat there at his desk with a cigarette hanging out of his mouth and scratched out a couple of CMOS ICs and some capacitors, and a very, very simple circuit that did the job. And just off the top of his head. Amazing guy.
So then he would have worked with like the head step timing that we see here.
I think the head step timing would have come from Wozniak. This is the stepper motor driver. And
here's Woz's more official sector format.
yeah, the sectors on the disk are not laid out in sequence. Sector 2 does not follow Sector 1. They are laid out because there's a latency between the time you read a sector and the time you want to read the next one. So it might be Sector 1, and then 3 sectors later is Sector 2, so that you can do continuous reading. And if you laid them out one after the other, then you'd have to wait a whole revolution to get to it. So he developed a sector map, the way the sectors on the disk should be laid out for the fastest reading.
Interesting. So not only efficient chip design, but it's very efficient software operation.
Yes, and this is a problem faced by file management systems today. Laying out the disk, and how are we going to do it? And as you get faster disks, you have to change it.
There's a couple of other things here. This crazy notes. Are these Woz's?
Yeah, these would be Woz's, and what it looks like here is he is essentially brainstorming how to write the code for the read-write track sector. So these are his thoughts verbalized on paper, which later all got put together in this listing right here.
And this is what Wigginton and Voss wrote by hand.
Yeah, this is the full read-write track sector after it was all developed and tested, and they had taken the opcodes that they generated by hand and entered them into the machine and actually got their read-write track sector working. And this is how they delivered to me the code for read-write track sector. And I later put these in punch cards and put them into the DOS. Amazing stuff. A lot of memories here. And here's the note, must not cross page boundary.
Must not cross the
Very nice.
I think of maybe one or two other things, and then we look through. If you see something jumping out, this is more of the read-write sector, DOS boot.
Yeah, can I see the DOS boot?
DOS boot, prom.
One of the circuits here is a PROM, a read-only memory, that has 6502 code in it. And so in the boot up process, you would read that code into the 6502, and then that had the read-write track sector enough to boot the DOS. So the bootstrap process was really a bootstrap process. You would end up reading some code off of here, which would read it in, and then that code would read in the boot sectors off of the disk. We call it bootstrap because it's lifting yourself up by your bootstraps.
So that's the bootstrap. And we looked at the, okay. That's the device address assignments, track assignments. This looks much more official here. And Woz's handwriting, simply writing company confidential on it.
Yes.
You know?
Yeah, as he was handing me the documents, he was writing company confidential on them. I guess he'd talked to a lawyer. These cards, when you plugged them in, they would go into an address space in the 6502. And those address spaces could either contain memory or they could contain electrical signals for things. And this gives the electrical signals, the addresses, and the electrical signals that control this card. So if you wanted to move the head, you'd send out a number to this address. If you were going through the state machine, these are the addresses that you would read or write to.
We looked at the state machine and, pin assignments. And none of this changed during the development. Your development.
No. Well, actually, these pin assignments, well, this is the pin assignment of the state machine. There's 256 byte ROM. These are the various pin numbers on the chip and what they were used for.
That's all of our state machines. Does the last document that certainly is fascinating is this April 10th, 1978. You know, dear Steve, to Steve Jobs, and he signs it twice here, and to me it's almost like he tried to sign with a fountain pen there, and it made a mess, so he signed there again with a ballpoint pen. I don't know, because he was into calligraphy.
Huh.
But this is obviously, it's an old photocopy. How did you come to have these Shep docs?
Well, usually, like I was saying, I would create the content, and then Shep would type them up. Actually, his wife would type them up, and then once they were signed, he'd give me a copy. So this is the original contract.
That's the contract.
And noted that this says will not have a sysgen. Sysgen was an IBM term that was used for generating the system. So, my anticipation was that a sysgen would be needed, but it was not included in this. Also, I was saying I was going to have a backup. So a way to back up a disk, a way of recovering a disk, and a file copy routine. This was all in that original contract, none of which I delivered.
But they paid you anyway.
But they paid me anyway. But I actually delivered a lot more than what was called for, but none of those utilities were delivered. The file manager was delivered, the basic interface was delivered, and none of the other stuff.
So in the rest of these letters, you've got, that's the system contract from May 10th of 78, so that's about midway through.
I recognize the words, but I don't think this produced anything like what was being said here. The functions got created, but they didn't get created in the way specified here. This calls for a boot and a format of a disk, and it all got done. It just didn't get done the way it specified here. This looks like another contract. This was a very vague contract. Paul is going to make the changes agreed upon. Price $500.
Right.
You know, nothing specifying what they are.
It might have been attached in some later document handwritten by you.
This is, I think this came, there's a notes of a meeting minutes, and this is a document that was produced as a result of him saying that I would fix certain things. These are the things that would be fixed.
That is your handwriting.
Yeah, this is my handwriting. And the time it would take. So, and maybe this is the agreed upon stuff for $500.
Quite informal in those days.
Yeah. Everything was just done. I mean, you know, it was mostly gentleman's agreement. And everybody was moving fast and nobody had time. If we had had lawyers involved, it wouldn't have gotten done.
Which is what John von Neumann told the people at the Institute for Advanced Study. I don't want any lawyers involved in building a machine. We'll spend more time and money on them than building the machine. Therefore, we're going to give away our plans.
Well, I remember trying to ship product at Logitech, things like digital cameras, and an enormous amount of time spent with lawyers. You know, things that had to be warnings about inserting batteries. You know, the design made it impossible to insert the batteries wrong, but the lawyers insisted.
You had to still warn.
Yeah.
That's a great picture. All right, I'm ready when you are.
Okay. So here we have, this says DOS 3.3 System Master. So this, when you booted DOS, it would relocate in memory. You could then create a master with it already relocated, so it didn't have to relocate. And so calling it a system master would be a relocated version. If you notice over here, there's a little piece of tape around here. That's write protect. So if I put this in and try to write on it, it won't write. And insert it into the drive. It would be nice if this was an actual machine and we could watch it boot up, because that would.
We can if you want.
Oh, really?
You want to plug
Can
it?
we do that?
Yeah, I got it all. Oh,
This.
where's the power?
Well, let me let's pause this.
Yeah, I'll just turn it off. This one seems to be lighting up. Wait a minute. There we go. What's that sound?
Okay, so that sound you hear is the stepper motor is pulling the head all the way back, so it knows where it is. It could be, that head could have been left in any position. So it's pulling it from the farthest position back, and what you're hearing is it's beating its head against the wall. But it ends up knowing exactly where it is.
Interesting.
And And so we're all booted up, and we can type in cat. It says syntax error.
Oh, catalog. You have to write the whole thing out. LOG. Cat LOG. Yeah.
Where's the backspace? A lot of stuff on there.
There's some basic programs there.
Looks like AppleSoft is there. Floating point basic, integer basic. A renumber program.
Might be a sorter there too somewhere.
Very good. I remember that old 40-column screen. That brings back a lot of memories. I don't know how many man hours I spent on a keyboard working on things. Sorry.
No worries.
Mike?
Hey, Paul.
Can I call you? Can I call you back?
Sure.
Okay.
That's great. I'm really glad we got to boot it up.
Cool. Yeah, actually, I just got a bunch of pannings and tip shots too. So unless you want to,
You got the audio as well from.
Yeah.
Yeah.
Okay.
Great.
To find out how long a particular opcode is, what is that? Is that in the ROM somewhere? It's F8BE?
Well, if we want to know where it is, we can go to this thing at the back.
Well, yeah, I think it's defined as a constant. It's,
Yeah.
I think I saw it, actually. Yeah. NSDS2. And I'm assuming that that's some address in the Apple II ROM. So was there some routine in the Apple II ROM that knew about 6502 opcodes, and based on what was the opcode in the A register would tell you, apparently store down in location 2F, how long that instruction is. See, in order to do the relocation, you have to know a lot about the opcode structure of the 6502 to know how long instructions are. Now, and I didn't see anything in here that did that.
The code that somewhere in here, I thought I had a comment saying, anyway, saying Apple code, but I'm assuming you're right.
Why would that have been a routine in the ROM?
There was a lot of the little stuff in the ROM that Woz put there. Sweet 16 was in the ROM.
Okay.
Uh,
Now, obviously, this is fragile because if a new version of the ROM comes out that changes, then this code is broken.
well, there wouldn't be a new version of ROM for any reason. I mean, if
Okay.
it's,
It's ROM, so.
Woz did things right the first time.
Okay.
So yeah, this somehow, I guess, I mean, there is a madness to the value of an operator. I mean, a method. On the 6502 operators, you could look at them and classify them into things that they did.
But I don't see any of that code in here, so,
No, you'd have to go to the Apple II
right.
ROM.
So you're assuming that this was that each of these was one block of just pure code with no data, no address constants, stuff
Right.
like that.
No, there were also those jump tables.
Yeah, and I guess that's what this is, right? This section up here is relocating address tables.
Mm-hmm.
And then this is relocating the code, and these are the lists of the address ranges that have to be relocated, and this is a list of the code ranges that have to be relocated.
Mm-hmm. I guess I built in some space.
Two additional ones, right?
Mhm.
Yeah, I mean, other than that mysterious call, this all makes sense. Right, you're looking to see if it's a range that needs to be relocated, otherwise you ignore it. You look to see if it's an opcode that is too small to have an address in it, in which case you don't have to do anything. And then you look for the end of the code in this segment, and when you get to the end of the segment, you go to the next segment. So you're stepping down this list. It's clever code.
Now, some of these things like, no, I guess not. I was talking about different opcodes. I think the opcodes, maybe things like DB are not official.
No, DB is not an opcode. That's just an assembler
No,
pseudo
they're
op.
directive, but
Yeah.
I don't think it's a 6502 directive, an official one.
Oh, right. Yeah, it could be. I think most of the instruction opcodes are the same as the standard ones.
Yeah, they are.
It looks like you may be going through this table backwards, right? Comparing to the beginning of the table to see if it's done. Let's see where you started.
And this is adding.
Oh yeah, and it's starting at code table plus 1 comma x. X starts out as 0. Yeah, so maybe we're going forward. But then why is this comparing to the beginning of the table? Oh, this is a little confusing. What's that db 6 times 4?
I think it's the size. So CD tab, the value at CD tab is the size of the table. Does that make sense? So,
Yes, okay, I see what you're saying.
yeah.
Right,
So there's 6 elements in the table,
right.
and they're 4 bytes long. So this is checking to see if I'm at
Okay.
that value.
I got it, okay. So x starts to 0, goes to the value of CD tab,
Mhm.
and increments of 4. Got it. Yeah, I thought CD tab was the address.
CD tab is an address, I think. See, CD tab plus 1.
Yeah,
CD tab is located at this address. And so CD tab would be this byte here, and then plus 1 takes you to the next place. So it's,
oh, I get it. So CD tab is the address of this byte, which contains the size of the table.
right,
Got it.
right.
So this is not a compare immediate, this is a compare with 1B.
hmm
Got it.
And then up here,
You start at the next location,
yeah,
right? Because that's the beginning of the first 4-byte quantity.
right.
All right, I get it. That's interesting. Were there no compare immediate instructions?
Compare immediate.
You know, where rather than having the address of a byte that contains the value to compare x immediate, I don't, maybe not.
I think, I'm trying to remember, if you had values in 0 page, or I forget, yeah, there. In 0 page, you had such things that you could do. You understand 0 page
Yeah,
in
yeah.
6502?
Mm-hmm.
So I think you could do compare immediates. And,
Mm-hmm.
been a long time.
Yeah, it's a pretty strange instruction set. But it was fun.
Yeah.
You could do a lot with very little.
These branch relatives were nice too.
Yeah.
So these are the vector tables,
Mm-hmm.
like init, load, save, run.
Yep.
So they pick these out and then do a JSR or RTS.
Mm-hmm. Yeah, because there was no indirect jump.
Yeah. What that's about.
It's a typo, I think. You're trying to get to here. Yeah, it's init 2A versus init A2.
Hmm.
I fixed that.
Thanks, Len.
So this is essentially getting a command.
Mm-hmm.
A lot of work just to read the keyboard, and
Yeah, I'm surprised there weren't routines in ROM that you could have used for that were already there for other purposes.
I think part of it was, I think, because we were going through BASIC.
Mm.
I don't know. The bug was to determine whether BASIC was in execution mode or not.
How big was the total code when you delivered it? You know, it wouldn't run in a 4K Apple II. It needed like an 8K,
I think Apple II's only came in 16K chunk.
60K.
Yeah, so it was within the 16.
Search is really the
Mhm.
volume table of contents search,
Right.
where you're doing the file name compares.
Mm-hmm. Looks like deleted files.
Are just marked as deleted. You didn't
Yeah.
reorganize the volume
Mhm.
table of contents, which makes sense, yeah.
Mm.
Branch if it's a deleted entry. That's the way most file systems work. You can't reorganize the directory each time.
The VTalk and the sector allocation stuff was what I would call an essential cylinder.
Hmm.
In my IBM days, you had the cylinders in the disk,
Yeah.
and you wanted to put that which is going to be accessed a lot in the central cylinder.
Uh-huh.
So I probably carried that over, and it was not on the, it was in an inner ring, middle
Okay.
ring.
Okay.
And then, as I recall, sectors were allocated in and out from that point, which is the way we did it in IBM.
It looks like you keep track of, pardon the pun, you keep track of a track that is entirely composed of free sectors. So this frees a sector, and then this frees a track of sectors. I'm a little bit confused by that.
It was 2 level.
Yeah, but why would you bother to keep track of tracks at all?
The tracks being the cylinders, if
Right.
you will.
Right.
And I think I was trying to manage the allocation of, like I say, getting a new track. Is it to the left or the right of the VTalk?
Mm-hmm. Okay, so here's the VTalk for the volume. Things like desktop. So where the directory sector is, DOS release number, volume number, maximum sectors in a file directory, allocation algorithm, bytes. Number of tracks on the volume, number of sectors per track, number of bytes per sector, so it's fairly configurable. Sector allocation area. Sectors allocated by bitmap, 4 bytes of bits per track. So there were 16 bits saying which of those sectors on the track were empty.
Yeah, well, the bits were on if they were available.
Bits were on if they were available, okay.
Did you ever think of doing a hierarchical directory structure, or this is just all flat? That was never in. I know that got added in the 80s in DOS and things like that,
Hierarchical directory, and not sure what you mean.
like subdirectories.
Where a file can be a directory of other files, like subdirectories.
Oh, no,
Yeah,
no.
yeah.
Too soon, too early, too complicated.
Yep.
Not enough disk space to even think about it.
Hmm.